Alright, human beings, welcome to round 2 of this hard milling adventure we're going through. So these are the results from last night, and I think I talked about it in the video, but you can see the kind of toolpath points, or the tearing, or the smearing, or the whatever you want to call it. So yeah, it looks nice, but the issue is those lines kind of get really defined when being tumbled. So it's not really going to work for an actual knife, the actual knife blade. At least not what I was going for. And then the other thing is the upper bevel has this nice weird cut in it. So maybe I drug a chip or something. So I also found out that the degree, this is actually 9 degrees is this slant. So I had the ball mill tilted probably too shallow. So we're going to go ahead and change that too. That's why the surface finish is almost, it's like significantly different on that upper portion. So yeah, we're going to try blend, the toolpath blend. I've never actually gotten blend to really have good results, or I'm not really sure I ever used it. I think I've generated toolpaths, like blend toolpaths, and then never went ahead and actually tried them. But I'm curious to see if blend's going to work. So blend kind of, you basically give it drive curves and then a drive surface, and it'll use the two curves to generate a toolpath between the curves. And it's kind of interesting, but the point density of it kind of looks a little weird. So I don't know if it's really going to work that good with this, with the controller and the speed I want to cut at. But let's go over some of the cam stuff for that side, and then we'll get to making poor results. So for this second side, same thing as the first side from yesterday, same clamp. We are going to probe the Z height, and then before we do this, something important to note is this op 2, 3, 4, whatever you want to call it side is resting on this boss here, and the boss is shaped to the bevel of the blade, and that is what's supporting the blade during this milling, and it works pretty decent, I've found, as long as you properly cut the blade in the first operation. So probe Z height, then we're going to do chamfer this pivot, we're going to do that scallop thing with the thumb slot to make it nice and smooth, and then finally we're going to come in and actually contour, and like I said yesterday, this is to match the two shoulders up against each other so there's no weird blend line, so it's an adjustable thing. Then we're going to add our bolt again, and same thing, Z height, probe because it's now changed. Rough out the bevel, which results in a really nice finish, and I kind of wonder if there's a way I could utilize a tool and some sort of finish to achieve close to a mirror, because that finish from yesterday, the mirror finish after roughing, is actually really nice, minus the swirl marks in it. So you gotta wonder if there's a way to utilize something like that. But for now, we're going to do a semi-finish, and this is a blend toolpath, and you can see the point density is kind of insanity. But the way blend works is you have a drive surface, and for this I picked that patch that's bigger than the bevel like I talked about yesterday. And then the drive curves are going to be, should be curves that probably don't touch each other, I've found, so you wouldn't want to select this curve as well, because what'll happen is it'll drive the tool path into the 0 point right here. Here, I'll just show you really quick instead of just talking about it. So if you select this and you go ahead and drive the tool path using that curve, it's going to force the tool path to go into this little corner. And what's going to happen is you're going to get tool rubbing essentially as it starts to collapse down in here, and that's not going to be good for the tool. So yeah, you kind of want to have these open contours, I guess, selected, but I am still learning how to use it, so don't quote me on anything because I'm still learning how to do everything. Yeah, so anyways, those two drive curves doing a negative offset that is basically double the value of our tolerance. Doing a 4.5 thou step over, and the idea with that is 4 times the feed per tooth. Oh, sorry, it's supposed to be 4 times the feed per tooth. And I'm just doing that because round numbers and multiplication sounds like a good idea. Also doing a really large lead in and lead out radius, and that's basically it. Leaving 2 thou, and then really important, we're going one way direction, and I'm just following the direction that Fusion would go for a parallel toolpath, meaning that the cutter starts up here, and then, does it start up here? Starts on this side of the model or the surface and travels this way. And then for the bevel, because the bevel is actually slanted in the other direction, the cutter starts down here, I think, and travels upward. Let me see. Yes, of course. It travels this way downwards. So I can never remember like the rules of thumb and which way you're supposed to be actually, like, when you're climb milling, if you're supposed to go up or down a curved surface. So I just used like parallel and then let it generate one, and then I just copied it for this. So something that's kind of important with blend is the toolpath direction is actually driven by when you select the contour. So if you select this contour before this one, it's going to drive the toolpath a certain direction. Whereas if you select this bottom curve and then selected this upper curve, it actually changes where the cutter is going to start. So that's kind of what I'm talking about as far as the direction, the downward or upward direction. And then same thing, point density is a little wild, so I'm sort of worried that the machine's not going to be able to cut this at its commanded feed rate, which we'll have to adjust from there. But basically we're going to go, you know, feed per tooth 12, what do they call it, 12 tenths. So yeah, basically 60 inches a minute, and then we're going to leave 2 thou. So we'll see if the machine doesn't be all jittery with all those points. And you can probably reduce the points by upping the tolerance, because right now it's 2 tenths, yeah, 2 tenths, so we could go to like 4 tenths or 6 tenths or something, and then change the smoothing as well. But I'd like to keep it low, just for this testing purpose. So I'm leaving 2 thou on both these surfaces because I want to see how this goes, and then we'll adjust the actual finishing toolpath accordingly. And I'm also interested to see what what basically 5 thou step over looks like compared to our 1.5 thou finish step over yesterday. And I'm also going to throw in a fresh cutter for our semi-finishing. So yeah, we'll start out with a good, nice, clean slate. And then really after that, it's same thing. We're going to do a trace, and that's going to chamfer the entire outside, engrave 20 CV on the blade because that's what it's made out of. And then finally, while this stuff is still attached, we're going to slot the blade out and yeah, and hopefully not chip the blade, because every once in a while you get unlucky and it chips the blade. After that, we basically finish up the knife by, where are the tabs that are supposed to be here? They're supposed to be, yeah, so these tabs are here. These tabs remain. Then what we're going to do is we're going to remove the bolts out of the tabs. We're going to put this center clamp here, and remember there's nothing now holding the blade because we just slotted the tip out. And then we're just going to contour, and then this is just essentially all we're doing. We're contouring and cleaning up where the tabs were, and then tilting it 90 degrees to do the jimping on the top, which is kind of cool. And of course I had it diagonal because I can, because it's in the 4th axis. I thought, why not? But that's basically it. So we're just doing finishing type stuff, and yeah, finish chamfers, and that's really it with this final 3/16 outside finish. Alright, cool. So this is the little boss I was talking about. Let me grab a dowel pin. So we're going to use our dowel pin here, and then we're going to use the dowel pin that we machined in the first section here where the pivot goes. It has a locating feature because that's a good way to do it, I guess. Make sure this is nice and clean. Literally any bump on here causes this thing not to sit flat, I've found. Like, it's got to be very, very, very clean. And then same thing with these back surfaces. You want to make sure there's nothing, no chips or anything, no weird protrusions. So I kind of like to snug these up equally at the same time, instead of just cranking one down and then going around and cranking them all like that. So I'll just kind of snug them up a little bit. Seem to get like a little bit better equal sitting on the fixture. And there's no air gap against our boss, so that's a good sign. So then I'll take the clamp here, and then I was tightening these pretty hard, but I don't think you want to tighten these too hard, because essentially you just want some rigidity, but I don't want to clamp this part of the blade down, because if you introduce any sort of like weird flex and then the cutter comes by, I found it promotes the tip of the blade chipping a little bit more. So I usually just give this a really nice, gentle, really not too hard tighten down. Just something to secure the end of the blade with, as opposed to nothing being out there. So, but I don't know, the issue with this whole system is it's not very easy, I guess, to set up, which is, it requires like some finesse, and that's not really that great as far as fixture stuff goes, but it works for now. So now we can start cutting this. For some reason the probe decided it wasn't going to probe, so that's kind of strange. Let's try that again. Okay, it's actually doing something this time. Obviously I pulled the dowel pin out of the pivot area. It did not cut a chamfer whatsoever. Guess I'll adjust that. Alright, we're going to do the little thumb area. And finally the finished contour to clean up that shoulder. Sweet. Next is the actual cutting toolpath, so get right to it. Alright, I went ahead and remeasured all the major cutting tools, just loaded it up. So we're going to rough and then semi-finish. Like I said, I put a new cutter in there. So the old one didn't look too bad actually, but just for the sake of testing. And yeah, this is a 6 megabyte file, so the point density, and this is after I changed it from I upped the smoothing to 4/10 as opposed to 2/10, so yeah, it's kind of ridiculous, and I don't know if the machine's actually going to be able to handle it very well, so we'll just have to see and adjust. So again, probe the Z height, and we'll see what changes. So it's 0.669 right now, and 0.731. It's almost the same exact change as yesterday on the other side. So same thing, we're going to rough. Alright, so that didn't go too bad. It's not the best. There is these interesting tear marks. Like stretch marks almost. But I'm pretty sure that's, you can see these little marks correspond to the gaps in the toolpath, like where the points look like they had weird gaps. So that's pretty interesting to see. So we still have 2 thou remaining. There's also this interesting line right there. It's kind of hard to see in the camera, but right there, it's like a weird split. The bevel still has stair-step marks in it, which is interesting, this swedge here. But I am only leaving 4 thou from that previous big tool, so that's probably why. And the finish is okay. So yeah. This is also, what is it? It's a 4 8/10 step over. So I wonder if going down to the really low step over we tried yesterday would help us or hurt us as far as finish goes. So yeah, I'm gonna give it some thought, and then we're gonna run the finish toolpath. Okay, so funny story. I got caught up trying to make the surface of the bevel be much better as far as surface curves go. So then I went into the rabbit hole of, you know, surfaces and ISO curves and curves. So, the last time I had the camera on, I think it was 5 p.m. and it is currently 11:20. So, I have got nothing done and I didn't accomplish what I wanted to as far as the curves go. So, I'm tired of wasting time. So we're just going to cut this using flow, the flow toolpath. The point density, not really what I want, but at the same time, I can just hand sand away my problems instead of wasting all my time. So that's for another day. Anyways, let's get to cutting this final bevel. I'm going to remeasure this first, and then we'll cut. Show me what you got. Pause. Well, that's completely incorrect. Oh, great. Well, now you guys can't see anything. Real nice. Well, that came out better than expected. Alright, so doing the final set of tool paths, we're going to take this bolt out, and I'm going to put that clamp there. We're going to slot the blade out, and then do the jimping, and then just basically clean up the outside, and that'll be it. And hopefully nothing catastrophic happens. But sometimes catastrophic things do happen. Alright, time to slot the blade out. Always a good time. Sounds healthy. Oh, look, it's a boy. Sweet. Didn't chip. Well, that's good. Alright, so the rest of this, just cutting the outside, jimping, really nothing exciting. So we'll skip to the end. Okay, so this is fresh off the mill. This side came out really good. Like a big improvement over the other side. So this is the other side. Remember we had those marks, if you saw the other video. Up here. And then this one has very, very, very little noticeable marks, like basically not noticeable whatsoever until I point them out. You probably can't even see them, but there is this one little chip here. Very, very minuscule. So I imagine what happened is a piece of metal or something got dislodged and then the cutter jammed it right into the surface or something. But other than that, the finish is really good. I actually thought the way the toolpath points came out, it would not come out as good as it did. So that's pretty exciting. And then obviously the rest of the knife came out really nice, chamfers and everything, along with our blended shoulders here. So yeah, it's nice to have some improvements every once in a while, finally. Like, I feel like I've been getting kicked in the teeth for the last couple weeks on these things, so this is a really good improvement, which is great. So what I'm gonna do, I'm gonna end the video here, but I'm gonna go ahead and try to blast this and see, and then like tumble it and see if the lines still show up. I'm sure on this side, or on this side, like they will, especially this mark here. But the goal obviously is to reduce the amount of hand finishing because it's completely unsustainable as in its current form. Like, I literally can't eat if this is like a long-term plan. So yeah, but yeah, exciting stuff. It is 1 in the morning here, so it's time to go walk turtle. Anyways, thanks for watching. If you like this kind of stuff, please subscribe and have a nice morning.